right, let's look at another example. This is a think, pair, share. So give this one a try first, and then watch my video for any help or assistance that you need. In a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to spend time with a disabled senior citizen. The program recruits among community college students, four-year college students, and non-students. In the following below is a sample of the adult volunteers and the number of hours they volunteer per week. Is the number of hours volunteered independent of the type of volunteer? Okay, so what we've got here is all of this represents our observed data values. All right, and here it's asking, is the number of hours volunteered independent of the type of volunteer? So specifically, the word independent is being used. And we've got two variables, right? Hours volunteered versus type of volunteer. Okay, so this is telling us here that we've got a test of independence to conduct. So what we're going to do is let's look at step one, our givens. I think it might be worth noting that nowhere in here does it give us a confidence level, right? So confidence level not given. So you can assume a 95% confidence level, which is going to infer a significance level of 0.05. Now let's see here. We need to calculate degrees of freedom. So degrees of freedom is going to be the number of rows minus 1 times the number of columns minus 1. Try and switch to an eraser. There we go. All right. And let's see, the number of rows that we've got are 1, 2, 3. It's going to be 3 minus 1 times the number of columns. We've got 1, 2, 3. So 3 minus 1. So that's going to be 2 times 2, which is 4. All right, so we've got 4 degrees of freedom. Now, one of the things that we're going to need to do is enter this data into the, oh goodness, into our calculators. Yeah, I wish I knew why my laptop did that. But oh well, it happens. All right. So we're going to have to put this information into matrix A on the Texas Instruments. Okay, and this is a 3 by 3 matrix, 3 rows and 3 columns. That means we need to make matrix B also to be 3 by 3. And in the numworks calculator, again, we'll also have to enter in a 3 by 3 matrix, okay? But that'll be inside the app that we do that. All right, so let's move on to step 2, and that's to set up our null and alternate hypotheses. So the null hypothesis is that the two variables are independent. So number of hours volunteered, and type of volunteer are independent. Okay, and that's going to be our original claim. And the alternate hypothesis is that the number of hours volunteered and the type of volunteer are dependent. All right. So step 3 is going to be to calculate our test statistic and p-value. All right, so let's do that first with the Texas Instruments calculator. So again, we have to go into the matrices. So I'm going to go into second and then look at the matrix options here. And I've gone ahead, so go to the edit menu. I've already gone ahead and put these values in the interest of time here. All right, so initially this was a 4x5 from a previous example. So you just have to type a 3 here and a 3 there, and it'll resize things. And then you can just type numbers over the old numbers. Okay. And make sure that the matrix you set up for your expected values has the same dimensions. So go to the edit menu, go to 3x3. I'm sorry, go to matrix B and make it a 3x3. Now you'll notice I've got leftover values from the previous example. It doesn't matter. Okay. All you have to do is make sure that the dimensions are correct. It will overwrite all these numbers. Okay, so you don't have to do anything with that. All right. So let's go to stat, tests, and I'll scroll up because I know chi-squared test is closer to the bottom. KR observed is a matrix A, which is a 3x3, and the expected is matrix B, which is also a 3x3. It would have been nice if they put the dimensions of the matrix in there. That would have been helpful, I think. But anyway, so let me put calculate, but I'm going to hold off doing that because I want to come over here to the NumWorks calculator. We'll go to inference, click OK, tests, chi-squared, homogeneity, independence. All right, now I put in the 3x3 values, but you'll notice I have an extra row and I have an extra column. So what I want to show you is that if you want to get rid of a column, select the column like I did, and you'll notice that there's the word clear above this backspace button. Clear is in orange. So with the column heading selected, hit Shift and clear, and it says all data in column group 4 will be deleted. Click that to confirm and click OK. Now it gets rid of all of column 4. And then I need to get rid of group D. Okay, this is leftover from my previous example. So I've got group D selected. I'm going to hit Shift and clear. I was afraid that was going to happen. Doesn't work that way. All right, then I guess we'll just have to go into each cell and delete it. I was hoping I could clear the entire row, but I guess I can't. All right, so now I've got, a 3x3 table in the NumWorks calculator. All right, so now I've got a 5% significance level. So I'm going to hit next. These are my expected values. I'm going to go down and hit next. And there's my chi-squared test statistic, and then there's my p-value. Let me come over here. Our degrees of freedom was 4. That's what I calculated. Let's go over to the Texas Instruments, 12.99, 0.011, degrees of freedom 4. Okay, so both of those look pretty good. So let me write that down. 0.113. Okay. So our test statistic is 12.99, and the p-value is 0.0113. All right, let's go to the next page, because we're out of room now. Let me transcribe this information. So all right, good. Serenity now. Come on. All right. So the p-value, 0.0113. All right, step 4, sketch our distribution. It looks right skewed. Okay, it'll always be right-tailed. Okay, we know that we've got a significance level 0.05. Reject the null. Fail to reject the null. Confidence level. Okay. We have to figure out our critical value. All right. So we need to go to programs, do inverse chi-squared. Okay, 0.05, degrees of freedom 4. So we have a critical value of 9.49. Okay, numworks. Click home, go to distributions, go to chi-squared, degrees of freedom 4. Okay, area to the right, 0.05, 9.49. All right, critical value of 9.49. Okay, so where is 12.99 relative to 9.49? So it's going to be here to the right of it. So this is going to be our chi-squared test statistic based off of our sample data. And if we follow that up, it's clearly showing that we're going to reject the null. The p-value is the area in the tail, right there. And the p-value is 0.0113. And if the p is smaller, reject the nuller. So this is a smaller value than the significance level. All right. So now we get to move on to the last step. So that's going to be step 5, which is to write down our results and conclude. So we just determined that we're going to reject the null, and the null hypothesis was our original claim. So the null is the original claim, and we're going to reject the null, which means this is going to be our outcome. So let's write that. There is sufficient evidence to support rejection of the claim that trying to switch to green. There we go. That the number of hours volunteered and type of volunteer are independent and that is with a 95% confidence level. Okay, that's our conclusion. All right, let me know if you have any questions.